In recent lessons, we've been talking about the preservation of fossils and looking at some of the factors that affect the preservation of fossils. Yet, when we look at this particular specimen, which is from a rock of early Paleogene age from America, it strikes us as remarkable. If we think about what makes a good fossil, the presence of hard parts, for example, looking at the petals of a flower preserved in the rock is quite staggering. And particularly when you even look at the details of the petals that are preserved. What we need to do in this lesson is to consider why a fossil like this exists at all. Because this is an example of a feature in geology, an important feature that we call exceptionally preserved fossils. What is it that will preserve fossils that really shouldn't be fossils at all? For this lesson, you need your handout on the Florissant fossil beds. Okay, let's go. There are examples of these exceptionally preserved fossils in different parts of the world. I want us to focus on one of these locations in particular. This is the Florissant fossil beds. It's in Colorado, in the Canadian Rockies, and I think shows a good example of this exceptional preservation. If we look at some of the fossils that are preserved within this particular unit, we can see some really quite remarkable things. We've seen already the petals of a flower preserved. This is a wasp fossil with incredible detail on an organism that normally wouldn't be a fossil at all, but in this case not only is a fossil, but we even see details of its legs, its wings, and even its antennae preserved. Now, this is exceptional. There has to be a geological reason for this type of material to actually preserve. We find lots of different examples of amazing fossils. These fossils are all found within an extremely fine-grained clay, really. It actually forms a very, very finely laminated deposit. Sometimes we call it a paper shale. It's very, very friable. It breaks apart very, very easily into these very thin sheets. And on these thin sheets of rock, on these thin laminations, we find these amazing fossils. Now, the environment this was deposited in was a very shallow lake. It's about 50 million years old or so. And in this shallow lake, you would have had animals living. You'd have had a lot of animals flying around on the top of it. And when that shallow lake, when those animals died, they landed in that mud, that very fine mud, and were well preserved. Sometimes this mud, sometimes the lake level dropped and the mud was exposed. We actually find rain prints within these sediments, which are like little meteorite impact craters as raindrops hit it. It really shows us a whole detail of the environment that existed at that time. Some of the fossils are a little more spectacular from the area. This is a petrified tree that grew around the edge of the lake at Florissant. So there's some fairly spectacular examples of 50 million year old trees. So we're getting a full picture of this environment. But the question is, why are these fossils preserved? Why do we find fossils here that we don't normally find anywhere else? And to do that, we need to look at the geology. We find within what we call the Florissant Formation, these sediments, particularly the shale units and the mud rock that's shown on the geological column here. the deposits from this shallow lake. Now, normally, such fragile deposits containing such fragile fossils would be actually very easily eroded away. So we can have the situation where fossils such as the wasps and the flowers might be preserved for a very short period of time, but then the sediment in which they are deposited, because it needs to be very fine, it needs to be deposited in a very low energy environment. As soon as there is any energy, it's just going to erode away that fine-grained sediment and destroy any fossils contained within it. Florissant is different because of a volcanic eruption. There was a volcanic eruption relatively close by, and that volcanic eruption deposited a thick layer of tephra, of volcanic ash, volcanic boulders, on top of this very fine-grained shale. If you actually look at this rock, it looks like it looks like concrete, and that layer of rock is about a metre or so thick. So deposited vertically on top of this very fine-grained sandstone, or sorry, very fine-grained mudstone, I should say, we've got a very resistant, tough rock that protects the far more fragile, far more erodable rock beneath. And because it was deposited from above, there wasn't a fast-flowing current washing this stuff in, the lake sediments weren't eroded away. And in the intervening 50 million years or so, that cap rock conglomerate and the upper pumice conglomerate have protected the fossil-bearing sediments beneath from erosion. And it's only now, as these sediments get exposed, we can start to find these frankly amazing fossils. And this is something I think that all the exceptionally preserved fossils have in common. It's there has to be some type of geological accident, some kind of odd event that's happened to both preserve and then protect the fossils that we find exceptionally preserved. There need to be an exceptional set of circumstances actually creating this deposit. If we just have the normal run of geological processes, then those fossils aren't preserved. We just get the hard part small invertebrates as our most common fossils. These exceptionally preserved fossils give us an incredible insight then into sort of snapshots of past environments and past ecosystems. So even though their number is going to be much, much lower than, if you like, normal fossil preservation, which is why they're exceptional, the value of these exceptionally preserved fauna is massive. Let's look at a couple of other examples to illustrate what I mean. Now, the geological word for these exceptionally preserved faunas is Lagerstein. It's a German word, it means resting place. And it's, as I was saying, where we get things exceptionally preserved. So it could be exceptional preservation, so where we get preservation of features that are not normally found. It might be just in the sheer quantity of organisms preserved, or it might be the fact that we get very rare fossils preserved. Let's look at some examples of each of these. This is, if we're really going full German here, the Conservat Lagerstein. These are words, by the way, you don't need to know. Okay, for A level we talk about exceptionally preserved fauna. This is where we get the quality of preservation being incredible, where we get preservation of soft parts that don't normally preserve. And this does give us some vital clues about the history and evolution of life. So, for example, the fluorescent fossil beds would be an example of a conservat Lagerstein. The picture you see here is the Morrison Formation in Colorado. This is a Jurassic deposit that is uh, very rich in things like dinosaur fossils and also some fish. Perhaps one of the most famous of these is the Solnhofen limestone in Germany. Um, this was a deposit from a very salty lagoon. We get some very fine grained limestone being deposited. And within that limestone, we get the deposition of some amazing fossils. Some of the things that lived within the lagoon, like horseshoe crabs, crustaceans. You can see one fish there dying as it was eating another fish. Um, we also get the preservation of organisms that were flying over uh, the this lagoon, died and fell into it, and were well preserved because of the saltiness of the lagoon prevented scavengers and decomposition. So we get like the dragonfly, pterosaurs, like you can see the bottom left, and perhaps most importantly on the bottom right there, a fossil called Archaeopteryx, the missing link between dinosaurs and birds. This is the Archaeopteryx fossil. Um, Incredibly rare, incredibly important, and incredibly well preserved, to the extent that we can even see the structure of the feathers uh, on its wing and tail that are still preserved. The example we looked at in the previous lesson of the Burgess Shale, um, another conservat Lagerstätten that preserves soft-bodied creatures, again because of a geological accident, um, with a submarine mudslides, burying all the animals that lived at that time in very fine detail because of the very fine mud. Um, all sorts of weird and wonderful animals in here from a crucial point of geological time where evolution was speeding up, what we call the Cambrian explosion. We find organisms such as this. This is Operina, the weird animal that swam around in the sea that had 5 eyes and this odd um, snout thing with a claw on the end of it, like nothing we find on Earth now. You know, the reconstructions of it like this are frankly bizarre. Yet we find it preserved in the Burgess Shale and nowhere else. There are some examples of what we call concentration or concentrat Lagerstätten, where we've got large numbers of fossils all together. The Morrison Formation would be an example of this. They're not quite as headline grabbing, but they are really important. We find examples of this here in Britain. A deposit called the Wenlock Limestone, a reef deposit from the Silurian that's chock full of fossils. Huge quantities that give us a good indication of the environment and an ecosystem that existed at that time. This is another example, a very famous one, the Brea Tar Pits from Los Angeles in California. About 30,000 years of an oil seep, hydrocarbons at the surface, where a whole range of quaternary mammals, saber-toothed tiger, mammoth, and many others, sort of got trapped and buried in the sticky tar in this tar pit that's excluded oxygen, and we get incredible preservation of the animals that were wandering around Southern California towards the end of the last glacial period. So, as the sun sets over the Colorado Rockies here, the value of exceptionally preserved fauna is enormous. In terms of the insight we get into uh, past environments, past ecosystems, and perhaps most importantly, the history of life, how life on Earth has evolved, makes these um, relatively small number of uh, Lagerstein, these exceptionally preserved faunas, massively important in our interpretation of the fossil record, and with it, the history of life on Earth. We now need to think about how we'd actually go about um, interpreting some of these ideas. And for that, we need to address one of the biggest ideas in geology. But that's for another lesson. I'll see you then.